Hello, in this video we're going to start going over aldehyde and ketone reactions. So first, let's review reactions that we saw with alcohols, specifically oxidation reactions. Remember, if we oxidize a primary alcohol, this is going to create an aldehyde, and then further oxidation will give us our final product, the carboxylic acid. We also saw that if you have a secondary alcohol and you oxidize it, you get a ketone. Now, if you try to further oxidize a ketone, unfortunately, that's where the reaction ends. We don't see any further oxidation. And this partly has to do with the absence of any hydrogen atoms bonded to the carbon in the carbonyl group. So the difference in reactivity toward oxidation is the main reason why aldehydes and ketones are classified in separate families, even though they're very similar in appearance. So some specific examples are given down below. If we oxidize benzaldehyde, we're going to add that oxygen right in between carbon and hydrogen on the aldehyde, and that will give us a carboxylic acid. So this product would be called benzoic acid, but we'll learn more about how to name carboxylic acids in a later chapter. Now, if we try to do the same thing with a ketone like acetone, we don't have a hydrogen on that central carbon, so there's just no reaction that occurs. So because aldehydes are easily oxidized and ketones are not easily oxidized, this allows us to test for the presence of aldehydes using special reagents. One of them is called Tollin's reagent, and then the other one is called Benedict's reagent. Now, ketones will not react with these reagents, but aldehydes will. So down below we have two pictures. On the left, we have an oxidizing agent in the first test tube. So that's the potassium dichromate that we've seen before. The second test tube contains acetone, so that is our ketone. And then the third test tube contains our aldehyde, benzaldehyde. So then what we're going to do is add about half of our potassium dichromate to the ketone, and then the other half to the aldehyde. And what we find is that the ketone does not react, so the color looks pretty similar to the color that we started with. It's just a little more dilute. But the aldehyde did react with the oxidizing agent, and it changed color. And a change in color is one of the clues that tells us a reaction occurred. So the benzaldehyde has been oxidized. Now we can also use Tollin's reagent to test for aldehydes. So Tollin's reagent is shown in this equation here. So there's two silver atoms. And each silver atom is bonded to two ammonia molecules. And basically what happens here is the ammonia molecule is going to attach to the oxidized aldehyde. And that is going to leave the silver atoms behind. And those silver atoms are going to deposit on the surface of the glass that the reaction is occurring in. And you actually get this mirror effect on the glassware. So it's really cool. You can actually see the reflection of the person taking the picture here. Now, ketones do not react with Tollin's reagent, so you actually wouldn't see any of this silver forming on the glassware. And if you want to see more information about this reaction, I've included a link down below. Additionally, we could use something called Benedict's reagent to test for aldehydes. And again, Benedict's reagent will react with aldehydes, but not ketones. So, for example, a lot of sugars have an aldehyde present, such as glucose. So down below, we have Benedict's reagent in this first test tube. And then we have a glucose solution that's really dilute. It's 0.5% glucose. And then we have a glucose solution that's more concentrated. So this is 2% glucose. And we already know that Benedict's reagent won't react with a ketone, so we just don't have a ketone as an example here, but you can see on the right-hand side that Benedict's reagent has been added to both test tubes, and they actually have different colors present. So Benedict's reagent is going to produce different colors based on the amount of glucose that's present, or the amount of aldehyde that's present. But again, if you had a ketone, there wouldn't be a reaction. Okay. Now, in addition to oxidation, we can perform reduction. And reduction will work on both aldehydes and ketones. So remember, reduction is the addition of H2 across a double bond. So if we have an aldehyde and we react that with our hydrogen molecule, one of the hydrogens will bond to the oxygen in the carbonyl group. The other hydrogen will bond to the carbon in the carbonyl group. So you can see that in our product, and this is going to produce a primary alcohol. And remember, primary alcohols are ones where the carbon bonded to the OH group is only bonded to one other carbon. Now, if we reduce or add hydrogen to a ketone, on the other hand, one hydrogen will bond to the oxygen, one will bond to the carbon in the carbonyl group. So you can see that in the product. And we're going to end up with a secondary alcohol, because notice that the original ketone has two carbon groups already bonded. So in the product, that means we have a secondary alcohol because our carbon that's bonded to the OH group is bonded to two other carbon groups. Okay. So let's look at some actual examples. Here we have propanal, which is an aldehyde, and it has 3 carbons in its chain, hence the prop prefix. And then we're going to add hydrogen. And remember, when we perform this type of reaction, we do need a catalyst. So we're going to use platinum. But you could also use palladium or nickel. Both of those work as well. So again, one hydrogen is going to add to the oxygen in the carbonyl group. The other hydrogen adds to the carbon, and that's going to give us one propanol. And notice that the carbon that's bonded to the OH group in our product is only bonded to one carbon group. So this is a primary alcohol. Okay, if we do the same thing with acetone, which is a ketone, again, one hydrogen is going to bond to the oxygen in the carbonyl group. The other one bonds to the carbon. We also add a catalyst, platinum, and we end up with 2-propanol. And again, notice this carbon that's bonded to our OH group is bonded to 2 other carbon groups. So this would be a secondary alcohol. So let's practice. Let's look at some examples of oxidation and reduction. So for the first problem, I'll give you these reagents here. And I want you to try to figure out what the product might be. In the second problem, we have something similar. And in the third problem, we'll do something a little different. Okay, so see if you can figure out the products for these three reactions. So you can pause the video, and when you're done, we'll go over it together. Okay, let's start with the first problem. Okay, so first, let's figure out if our starting material is an aldehyde or a ketone. So it looks like our carbonyl group has two alkyl groups, one on each side. So that tells us that we have a ketone. And then potassium dichromate is an oxidizing agent. And do ketones oxidize? No, they do not. So this would actually have no reaction. So ketones do not oxidize. Okay, let's look at the reaction below that. So let's find our carbonyl group. Okay, so it has an alkyl group on one side and a hydrogen on the other. So is this an aldehyde or a ketone? An aldehyde. And we have our oxidizing agent again. And do aldehydes go through oxidation? Yes, they do. And where does the oxygen add? Right between the carbon and hydrogen on the aldehyde group. So our product will look pretty much the same, except now we have an oxygen next to the hydrogen. And what type of functional group did we create? A carboxylic acid. Okay, let's look at our last problem. Okay, let's find our carbonyl group. We have an alkyl group on one side, a hydrogen on the other. So that tells us we have an aldehyde. And we're going to add, it looks like, two hydrogens across our double bond. So again, one of those hydrogens adds to the oxygen, one adds to the carbon. So let's draw our product here. Okay, so we've got our two hydrogens that added across the double bond to create an alcohol. But is this a primary or secondary alcohol? Well, if we look at the carbon that the OH group is attached to, it's only bonded to one other carbon group, this three-carbon chain. So this would be a primary alcohol. And in fact, what would the name of this alcohol be? So we have four carbons in a chain, and the OH group is on the first carbon in the chain. 1-butanol. Okay, so let's summarize what we've learned so far. And we'll just draw this or write this out in kind of generic terms. We won't draw any molecules here. Okay, so we saw that if a ketone is mixed with an oxidizing agent, there is no reaction. However, if an aldehyde is mixed with an oxidizing agent, we do get a product. And what type of product do we get? What functional group occurs? A carboxylic acid. Now, if we mix a ketone with hydrogen and platinum, we do see a reaction, but what kind of product do we form? An alcohol, and would it be primary or secondary? Secondary. Okay, and then if we do the same thing to an aldehyde, what type of product do we form? Also an alcohol, and it would be primary. Okay, so hopefully this helps you to remember the different reactions, but again, I will post flashcards for you to kind of go over, and that can help a lot when you're studying for the exam that's coming up. Okay, in the next video, we're going to go over some more aldehyde and ketone reactions, and then we'll kind of do the same thing. We'll do some practice problems. We'll also summarize what we've learned, and then we'll probably be done with chapter 14. So I will see you then.